Okay, so we're going to find the center and radius of this circle. Say you have x squared plus y squared minus 2x plus 4y minus, let's do plus 3 equals to 0. And we want to find the center and radius. Okay. So we're going to complete the square because you want to identify the center and radius from the standard form. So the standard form of a circle is in this form. You have x minus h squared plus y minus k squared is equal to r squared. Okay, so we're going to group these two together and these two together, and the constant term, I'm going to move it to the other side. So if I do that, I have x squared minus 2x, and then leave a space for completing square. Then we have the y variable, y squared plus 4y, leave a space, equals to -3. Now, who remembers how to complete the square? What do I add here for the x variable?
You're gonna add 1.
So we're going to add 1 because you take half of this value and then you square it. So you take half of it and you square it, you get -1 squared, that is 1. So 1 goes here, but you always have to remember that this must be in balanced equation. So I also add 1 to this side. So you do the same thing on y variable as well. So what's the extra number we're going to add for the y variable?
4.
4, good. So I add 4 here. That means I'm going to add 4 here as well. Okay, so that completes the completing square method. Now we write each of these as a perfect square. So this is our, now what's the perfect square for that term? Alberto?
X minus 1 squared.
X minus 1 squared. And what about the y variable?
Y plus 2 squared.
Y plus 2 squared. And on the right hand side, we just combine these numbers. So we have -3 plus 4, that's a 1, plus 1, that's 2. Okay. Alberto, did you have a question? I'm sorry, I missed your hand for a long time.
No, you guys, I was going to answer it. It's all
Okay.
good.
All right, cool. So continuing on, this is the standard form of a circle. So now, what is the center? Who can tell us the center?
Would it be 1, -2?
So this is your h. This is your k. Well, k, because it's positive, you can write it as negative. So that would be -2 for k. So our x coordinate is 1, y coordinate is -2. That's the center. Now, what about the radius? What do you guys think? What's the radius of this circle?
It's going to be square root of 2.
Square root of 2, because this is r squared. So if you want to solve for r, you take the square root. So the radius is the square root of 2. So there you have center and radius. Now, same type of problem can be worded differently, where I give you the center and the radius, something like this, and you have to give me the equation of the circle. So just going backwards. Any questions on that?
I have a question. When it says to put it into the a and then parentheses x minus h squared plus k form, how would I do that?
So that will be for quadratic. So say I give you a quadratic. So this is a different example. F of x equals maybe 2x squared plus 8x minus 2. and you want to write this in standard form, which is f of x is equals to a times x minus h squared plus k. That's the standard form of a quadratic. So you do the same procedure, you complete the square, but you are only completing square once for the x variable. There's no y variable. For circle, you do the same thing twice, but for quadratic, to express them in this form, which we call it the standard form, you complete the square just once. Does that make sense, Rita?
Do you think you could go through those steps if you don't mind?
Yeah, we'll do this one, yeah. Rihanna, did you have a question?
Oh, no, it's okay.
Okay, all right. So I'm gonna go ahead and, well, any questions on circles? Remember, they're important, so make sure you know how to find the equation of a circle from given center and radius, or know how to complete the square to put it in standard form, so know both directions. Any questions on this problem?
On the exam, are you going to give us any formulas, or should we have them all memorized?
You have to know them, just like our first and second test.
Okay, thanks.
Okay, any other questions on this? All right, so let's go ahead and do this problem where we also want to complete the square, and then we're going to write this in standard form, which is this form, a times x minus h squared plus k, where this it has a vertex at h comma k. And it's a parabola because it is in the form of x squared. So let's go ahead and do that. So now for this problem, we're going to complete the square, but before that, we need to do one extra thing. Because this coefficient is not 1, you have to factor out a 2 from these two terms, from your quadratic and the linear term, so that the coefficient of x squared is 1, okay? So if I do that, my f of x looks like 2 times x squared plus 4x, leave a space, and then -2 still waiting outside. So what I have done here is I factor out a 2 from the quadratic and the linear term. So now this coefficient is 1. Any questions up to this point? Okay.
Why didn't you? Oh, sorry.
Go ahead. No, go ahead.
Why didn't you also factor the -1? Like to get the -2, wouldn't it be like
From
in the
here?
parentheses? Wouldn't it be? Yeah, there.
So that's the constant term. So it's not needed in the completing square procedure. So you can just push it all the way in the back. Completing square only involves the quadratic and the linear factor, as you saw it in circle. Now, same thing applies to quadratics. When you're completing square, you're only working with the linear term, which is this one, and the, sorry, I highlighted the wrong thing. Linear term, which is this one, and the quadratic term. And the constant, you just leave it further down. So now let's continue on. I'm going to take half of my b term, that's this one right here, and I'm going to square it. That gives me 2 squared, which is 4. So 4 is what I'm going to add inside the parentheses. Now, maybe I should use a different color. Now, overall, we didn't really add 4, right? What did we add overall? Who remembers?
2 times 4?
Exactly, because this is all inside the parentheses. So overall, we actually added 2 times 4. So you also need 2 times 4 on the left-hand side, so you keep it balanced. So this is the one extra step you have to remember to do every time you're completing the square for a quadratic and the coefficient of x squared is non-zero. Sorry, it's not 1, not non-zero, not 1. Now, once I do that, I have 8 plus f of x on the left side And on the right-hand side, I have my perfect square, 2 times x plus 2 squared, and negative 2 still hanging out there. Now your goal is to solve for f of x, to subtract 8 from both sides. So your f of x is equal to 2 times x plus 2 squared minus 10. Now that is in standard form. That's exactly in the form that we want it. F of x equals a times x minus h squared plus k. Any questions here? Okay, so now what is the vertex? What's the vertex for this parabola?
Would it be -2, -10?
So the x coordinate is -2 because it's always opposite of what we see inside the parentheses. And y coordinate is simply -10. That's the vertex. Any questions on this problem? Chelsea, go ahead.
Yeah, why would it be -10 if the formula has a positive k?
Well, so k, so the vertex here, it's going to be h comma k. So it's taking the sign from the form. Here, our sign is a -10. So that's why it takes the sign -10.
Okay, and then the reason why it's -2 because it's always the opposite?
It's inside the parentheses, yes.
Okay, okay.
Good. Any question on this problem? Okay, Amy, go ahead.
Does that rule also apply when you're trying to find the center of a circle?
Yeah. So if you look
Okay.
at our previous problem, so it looks a little messy. You can see that our h and k are, h is 1 and k is -2. Any questions? All right, so any other question? No, do you guys know how to sketch this? This is a parabola. Now, sketching is also important, so make sure you know how to sketch them. Now, just to sketch it roughly, so we don't spend too much time on one problem. Now, will this parabola be facing upward or downward? What do you guys think?
Upward.
Upward, right. So roughly sketching, it's gonna look something like this because the coefficient or a value is positive, and this is right here is the vertex. That's -2, -10. Now, will this be a minimum or maximum point?
Minimum.
Minimum. So this has a minimum point. So the vertex represents minimum point. And the minimum value would be -10. That's just the y coordinate of your vertex. All right.
I have a question.
Uh-huh.
So for on the exam, would you want us to specify the zeros or no?
If the question says to find intercept, then yes.
Okay,
Mhm.
got it. Thank you.
No problem. All right. So any other questions?
Yeah. How would we know when the parabola is facing either right or left?
You mean up or down?
Oh wait, do we not have to know like at a point in time where it's facing right or left?
So do you mean transformation when it shifts to right and shift to left?
No, I'm talking about, how do I explain it? It's like when the parabola, say if you turn that parabola 90 degrees to like right, do we have to know that or no for this exam?
Something like this?
Yeah.
Oh, no, we didn't rotate any of our pictures. We did shifting right, left, up, down, and reflecting.
Okay, thank you.
Right? So those are the only transformations we did.
Professor?
Yeah, Brianna?
So Yes, so if the coefficient was odd, then the graph wouldn't have looked like that parabola. It would have looked like that other one, the
Well, not the coefficient, the power.
power,
So,
yeah.
So if you look at the original question, this is the original question. And we just wanted to write it in standard form, which is the special form of this function. So that's why it looks like a parabola, because the power is even. If the power is odd, then we don't call them parabolas, right? We just call them cubic function if it's third degree and so forth. So I don't know if that's what you were referring to.
Yeah, that's what I meant, not the parabola, the other graph that kind of looks like a, I don't know, like a, it's not a straight line, but like it goes in like a curve kind of thing.
Right. So if you had to like say graph something like this, well, not really graph, maybe determine the end behavior. So we didn't really graph these functions. Say x cubed, x minus 4 squared. And you want to determine the end behavior. Now for something like this, you want to look at the degree and the leading coefficient. So is this something you want to see?
Sure.
Okay, so if I'm looking for the end behavior, then I'm looking at two things. I'm looking at the degree, meaning the highest power, and I'm also looking at the leading coefficient. So what's the degree of this polynomial?
3.
Well, almost. It's not really 3. Not 4.
Oh, would it be 4? Oh.
No.
Would it be x to the 5th?
5th power, right? So the reason it's 5th, because this is a third degree. And if you expand the second factor, that has a second degree. So it's actually a 5th degree polynomial. So let me show you how you would expand this. Now you don't really have to expand it. You can just look at all the highest power and add them up. So this is x to the 3rd, x minus 4 times x minus 4. If you expand this, you have x cubed times x squared minus 8x plus 16. And then here's your highest power, x to the 5th minus 8x cubed plus 16x cubed. So you see that the highest power is right here. I don't know if you guys can see that. That's, sorry, it's a weird color. I don't know why I use that. So you see that the degree is 5. Now, what about the leading coefficient? Is it positive or negative?
Positive.
Positive, right? It's the number in front of our term with highest degree, so it's positive. So because it's odd power, bigger than 3, and leading coefficient is positive, at the end, it's going to behave just like a regular x cubed. So it'll be like this. Now, if the degree was odd and the leading coefficient was negative, then it'll be the reflection of this, which will look something like that. And then you start writing as x goes to infinity, blah, 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 all of that stuff we did. Does that make sense, guys?
Yes.
Okay. All right, so any questions on this kind of stuff? And we didn't really graph these type of functions because we just didn't have that time. But for something like this, the most I will ask you is finding the zeros or the end behavior, not sketching. Sketching will be either parabolas or exponentials or logarithms or a line. Those are the sketching ones. Olivia?
Could we go over a problem in which we're to look for the y-intercepts and the x-intercepts? So like solving that and then graphing.
Now, which type of function do you want to look at?
I believe on the exam we had a quadratic, so could we do that, please?
Okay, so let's take a look at so say you have f of x is equal to x minus 2 square plus 4. So let's take a look at that. Now that's a parabola, right? And we want to find the x and y intercepts. And then we're also going to sketch. Okay, so why don't you guys go ahead and try? I'll give you a minute to do that. Okay, so let's go ahead and start. So for x-intercept, who remembers what's the rule? How do we find x-intercepts? Anyone?
We set x equal to 0.
No, not quite.
We set
Set y to
we set
0.
y equals 0.
So we set y equal to 0. Remember, for x, you set y to 0. For y, you set x to 0. Opposite component is 0. So I'm going to set y equals 0. Y is our f of x. So that means we have, what do we have? 0 is equal to x minus 2 squared plus 4. And then I start solving for x. I'm going to go ahead and subtract 4 from both sides. I get x minus 2 squared. And then I take square roots on both sides. That gives me square root of -4 is equal to x minus 2 plus or minus. Well, now here's a question for you. Do we have a number for this on the real line?
No, that's imaginary.
Exactly. So that means that there is no x-intercept. So we're unable to solve. That means the graph doesn't intersect the x-axis. Any questions on that?
Would that mean we have a horizontal asymptote?
Well, that's not what it means because this is parabola, right? Parabolas don't have asymptotes. Only
Oh, right.
logarithm and exponentials and rational functions. It just means it's just all the way up there. It never comes down to the x-axis. But good point. Now, what about the y-intercept? How do we find the y-intercept?
Set x to 0.
So we're going to set x to 0. And then we solve for y. So I have f of 0 is equal to, so what's the equation? So we have 0 minus 2 squared plus 4. 0 minus 2 squared plus 4. And let's find the number. So this is -2 squared plus 4, which is 4 plus 4. That is 8. So the y-intercept is 0, 8. So the graph does intersect the y-axis. Any questions on that? Okay, well, let's take a look at the graph, right? Now we could actually graph this function by looking at it by applying transformations. So why don't you guys tell me what kind of transformation is this?
That would move the parabola to the right, like the x values to the right.
Right, so if you remember the transformations we did, that's you start with the parent function or the basic function x squared, and you shift right 2 units. So this means that we're going to travel right 2 units. And then what is this plus 4?
Up 4 units.
So this means we're going to go vertically, so up 4. So when you go up 4 units, that's when there's no x-intercept. So that's one way to tell just by looking at the function. But of course, we don't always do that. We just straight go ahead and set these components to 0. But this will be another way to justify your answer that there is no x-intercept. So now we're ready to sketch. So I know the y-intercept is 0, 8. So let's plot that. So here's my XY plane. And 0, 8. Let's suppose this is 0, 8. So shifting 2 units to the right, 1, 2, and then 4 units up. Let's suppose this is 4, because this is 8 right here. And just create the parabola. So now you guys know by now I can't draw parabolas. Doesn't matter how many time I draw this, still can draw parabolas. Here we go. Let's do that side first. Let's try again. But hopefully you guys got the idea how this looks like. Something like that, okay? Okay. I think that's more acceptable parabola. So you see how it never comes down to the x-axis, it's just all the way up there. Therefore, there is no x-intercept, y-intercept is 0, 8. This is our f of x equals x minus 2 squared plus 4. Any questions on this? Okay, well, any other questions?
Professor,
Uh-huh.
in what cases would we have to use the circle distance formula? Is that to find the radius or the diameter?
So it depends. So you could, so if I give you the endpoint of a circle, then you can use the distance formula to see how far these points are. And then if you take half of that distance, that's your radius. Or you can take the midpoint between the endpoints, that's your center, and then find the distance from the midpoint to any of the endpoints. That's your radius. So it could be interpreted in 2 different ways.
Okay. And use lastly for the ellipse, you said that we had to know, do we have to find the vertices and the foci or just the vertices?
No, I'm dropping that. You don't have to worry about that. Yeah. So
okay.
just circles, center and radius.
Oh, okay. Thank you.
Yeah. All right. Any other questions?
Can we do a problem where we use the distance formula?
Distance formula. So let's find the equation of the circle. If the endpoints are, let's see, let's do -2, 4, and 3, 7. Okay, so let's go ahead and do this. I'll give you guys a minute to think about, and then we'll start. Okay, so hopefully you guys had a chance to work this one out. Now let's imagine this, right? Let's take a look at this picture. So here's a circle. Of course, I'm not drawing it on the XY plane, but suppose the XY plane is there. Let's say this is -2, 4, one of the endpoint, and let's say here's 3, 7. Let's suppose that. Now that's the diameter. Okay, so if you want the equation of a circle, you need to find the center and you need to find the radius. And from there, we can fill in the equation of the circle. Now, how do we find the center? Who can tell us? This is the center. What do you guys think? Matthew?
We have to find the distance between the 2 points and then divide that by 2.
All right, so that'll give you the radius, not the
Mhm.
center, right?
No, this thing.
So center is a point. Another way of saying center is actually the midpoint. Right? Do you guys follow why we had to find the midpoint? So now what Matthew said is you find the distance between these 2 points and you take half of it because r is actually d over 2. It's half of the distance. So do we agree with that if we find the distance between these 2 endpoints, you get the diameter, and when you take half of that, you get r. Do we agree with that? Does it make sense? Let me know if that makes sense. Okay, cool.
Yes, please.
Thanks. So now who remembers what is the distance formula? Anyone remembers the distance formula?
Is it the square root of, I think, like x1 minus y1 squared plus the square, I don't know, sorry.
Yeah, you're close, but that's not the right formula. Someone else want to try?
Is it x2 minus x1 squared plus y2 minus y1 squared?
Mm-hmm. That's right. So that's the right distance formula. So it does have that square root in there, and it has those, you subtract those coordinates. Now let's label these points. Let's call this one x1, this one y1, this one x2, y2. Okay, I plug them in. So I have a square root of x2, that will be 3 minus x1, that is -2 squared, plus y2, that's 7 minus y1 is 4 squared. And then if I compute this, I have a square root of 3 minus -2, that's 5. You square, you get 25. Plus 7 minus 4, that is 3, right? You square, you get 9. Okay, so now this is simply square root of 25 plus 9, which is 34. 34. Yeah. Yeah, 34. So D is 34, square root of 34. But D is the entire measure from here to here. That's square root of 34. But we want R, half of that. So our radius is going to be D divided by 2. So that would be a square root of 34 over 2. That is the radius of the circle. Sorry, it didn't turn out nice because I just made the question on the spot. But of course, in the test, you'll have nice numbers to work with, meaning whole numbers at least, or fractions or something that simplifies. Now we have the R. Now we need to find the center. So R is checked. Now, how do we find the center? What did we say earlier? How do we find center? Anyone remembers? What was the?
Do we use the midpoint formula?
So you find the average of those 2 points because that will be the midpoint, which is the center of this circle. So we need to know the formula for the midpoint. So the midpoint formula is x1 plus x2 divided by 2 and y1. So it's just the average of the 2 points. So you can think of it that way. y1 plus y2 divided by 2. So that is the midpoint formula. So let's again plug these points in. We have x1 is -2, x2 is 3. So -2 plus 3 divided by 2, that will be the x coordinate. And y1 is 4 and y2 is 7. So this is 4 plus 7 divided by 2. So this will give us -2 plus 3, that's 1/2. And 4 plus 7, that's 11/2. So those are our midpoints, or this is the center of the circle. So any questions on radius and the midpoint or the center? Okay, now we write down the equation, right? So the equation of the circle is x minus h squared plus y minus k squared is equal to r squared. So h and k are the midpoint or the center, right? So this is my h, this is my k, and r is what we found right up here, square root of 34/2. So substitute them into this formula, you have the equation. So this is x minus 1/2 squared plus y minus 11/2 squared is equal to a square root of 34/2 squared. And then we try to simplify that. This would be x minus 1/2 squared plus y minus 11/2 squared is equal to, now square root of 34/2 squared, for the top, the square root cancels, you have simply 34. And on the bottom, 2 squared, that would be 4. Now, can we simplify 34 and 4? Maybe by 2, right? 17 times 2, right? Yeah, so I can actually simplify that to be x minus 1/2 squared plus y minus 11/2 squared is equal to 17/2. So there you go. That's the equation of the circle. Any questions? Let me know if you guys have any questions on this.
So would the center be 1/2, comma 11/2?
That's the center right here. And the radius is what we found for half of the distance. Any other questions on this? Okay, well, any other questions? Matthew, go ahead.
Yes. How come from, oh wait, so you got 17/34 by just taking 2 out of both equations, right? Just taking 2 out of the top and the bottom?
Right, so I simplified the radius by 2. Because I see they have a factor in common. And here, the square root and the square cancels for the 34, and then the 2 gets squared. That's how we get 4 on the bottom.
Oh yeah. Also, so just to be sure, the final has the same like restrictions as the last midterm, right? Like we won't do long division, or we won't do the or we won't do the half-life or anything.
No, if you look at the study guide, long division could be on the final.
Oh.
Yeah, and the decay problem could also be on the final. So that was only for the second test that I modified.
Okay.
Okay. Amy, go ahead.
Would we be able to do a question about half-life right now?
Sure. Do you have one in mind?
No, not really.
So let me see if I can get one from the book. So, okay, so what do you guys think? How do we do this problem? Who can tell us? Anyone wants to try?
Would we try and find maybe the R first?
So you always want to find R first. That's the key. So find R. So I'm going to solve for this variable, right? So what are we given? So we know the colony is growing exponentially, blah, 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 right? From 200 to 500 in 100 minutes. That info will help you to find R, the rate at which it's growing. So we start with 200, that's P. And when T is 100, the amount P of 100 is 500. I feel like we did this problem. Yeah, maybe. Let's do it again, right? It doesn't hurt. So I'm going to find R. 500 is equal to 200 times e to the R. T is 100 minutes, so that's 100. Divide both sides by 200. You have 5 over 2 is equal to e to the 100R. And then we take natural log, so you can bring down the power and e will cancel out. This gives you ln of 5 over 2 is equal to 100R, and R is equal to ln of 5 over 2 divided by 100. So that's the rate. And then we'll plug this into the formula to figure out the model. So we'll do the same thing we did for previous problem. So I plug this into my model. My model P of T is equal to the initial amount, that is 200, e to the R. R is what we just found. So I'm going to write this as 1 over 100 times ln of 5 over 2. So that 100, I just write it as 1 over 100. So that it looks something like this. I have 1 over 100 ln of 5 over 2, all of it in exponent times t. Now you do what we did before. You move this as an exponent for ln and cancel e and ln. So move this as an exponent. That gives us 200 e and ln of 5 over 2 to the power 1 over 100 times t. And now e and ln can cancel out, just like we did before. So a lot of this procedure are repetitive, but make sure you know how to do them, okay? So this gives me 200 times. Now, if e and ln cancels out here, the base 5/2 will come down as a base, and you will have 1 over 100 times t. That's simply like t over 100. That is the model P of T. So once you have the model, now you can answer the question. What's the question asking us to find? How many minutes does it take the colony to double in size? So what does that mean? What are we looking for? What do you guys think?
I think we're looking for T.
So what else? We're looking for T. What's the condition?
It would be like 2P is equal to what we just like created.
Exactly. So we're looking for the time. This is what we're looking for. So the amount is 2P. So what we just found, we set it to 2P, or 2 times P, and P is 200. So you can say 2 times 200, or you can say 400. But again, the initial amount will always cancel out when you're solving for time in these type of scenarios. Now, so does it make sense? That will be the setup for this problem. Okay, so I'm looking for time. So P of T is double the initial. So let's put the initial there. So it's 2 times the initial, that is 200, is equal to 200 times 5 over 2 to the power T. That's what we're looking for, over 100. And we do the usual, right? Divide both sides by 200. So you see how the initial will always cancel out. And this gives us 2 on the left-hand side. On the right-hand side, 200 cancels out. You have 5 over 2 to the power t over 100. Now again, apply natural log so you can bring down the power. So you have ln of 2 on the left-hand side. On the right-hand side, you have t over 100 times ln of 5 over 2. And isolate for t. T will be 100 ln of 2 divided by ln of 5 over 2. That's the time when the amount will double at this rate. Matthew, let me know if you have any questions on this.
No, I think it's very clear going over the second time.
Okay, sounds good. Now we could do the same thing with money, right? Change the scenario. Instead of talking about bacteria, you can talk about money, putting it in a bank account or saving account, and everything follow exactly the same procedure if we're compounding it continuously. So you have to read that carefully. If you compound it for a certain period of time in a year, then you have to use different formula rather this one. Do you guys know what I'm talking about? Let me know if you have questions. So if so what I was mentioning earlier, that if for money ones, right? If you compound it, let's say n times a year, not continuous, then we use the formula. The amount is given by P. Well, why don't you guys tell me what's the formula if it's not continuous?
1 plus, I think it's like the rate over t.
N.
Oh, and to the power of n times t.
Exactly, where n represents the number of time you're compounding it in a year. So know that formula apart from continuous growth or decay. That's another one we saw. All right, any other questions?
Please. Will we also do the other variation? Like, I forgot what it was called, but the first one we went over was p times 1 plus r over t to the power of t. Yeah, I forgot the name for it.
So that's the same formula, but that one is compounded once a year. Right?
Yeah, but that's
n is 1. No, we did simple interest, right? We did simple interest before. Simple interest is just where we don't really compound the rate, right? You just you start with some amount and you charge the person, or the bank charges you a rate, and after a certain time you just return whatever.
So it's just
yeah,
adding the rate.
Exactly. So for simple interest, the interest is paid only on the amount, so you don't compound the interest. So your amount, it's going to be, so what was the formula I gave you guys?
Is it P R T?
Oh, almost. So you could think of it as P, the amount, plus PRT. That's the simple interest, where the interest is only paid to the amount, not on the interest. So the question would not mention compounding a certain time in a year. Okay, so those are the keywords. And if you rewrite this formula, this is just P times 1 plus RT. That's only for simple interest. So if you want to review simple interest problem, I think we had one in one of the quizzes. So you can take a look at that or what we did in class. Right, any other questions? All right, so yeah, Matthew, did you have another question?
Really quickly, I know this is lasting a long time.
Okay, no problem.
Could we go over the area of a circle?
Area of a circle. Yes. So you mean a sector, right?
Yeah.
Okay. So
Yes.
So area of a slice, or sometimes we also call it a sector. It means you're just looking at a portion of a circle, not the entire circle. So remember, I told you guys, this is the formula you want to remember. So if you have a circle and you're looking at only this much of it, you want to know the area of that. That area is given by 1/2 r squared theta, where theta is measured in radians. So we had I think there was a question on the test. So why don't I pull it up? Let me go ahead and do that. Okay, so hopefully you guys have an answer. So first thing I'm gonna do is to just draw the angle. So I know theta is equal to 390 is really 360 plus 30, right? So we go around one complete circle, that's 360. We come back to 0 because 360 is equivalent to 0. And then we go around again for 30° more. So this will terminate where? Which quadrant is 390?
Would it be in the first?
First, right? Because 360 means you go around and then back to where we started, right? So I can kind of ignore that piece and then just sketch 30. So that's 360. 30 is just right there. So that's the triangle we're looking at. So I drop a perpendicular line to the x-axis, create this angle. So I know this is 30. Now, how much is this right here up there? What's the angle at the upper corner?
60.
60. So we're looking at a 30, 60. Now, remember I told you guys that across from 30°, that length is always 1/2. And across from 60 is always square root of 3/2. Those are the endpoint. Now, because you're in the first quadrant, your x and y are both positive. So the endpoint is going to have the x coordinate, square root of 3/2, that's across from 60. And across from 30 gives you the y coordinate, 1/2. So that will be the endpoint. Let me know if this makes sense.
So is the angle 60 degrees because they add up to 90? Is that like how you figure it out?
Well, not that it adds up to 90. The entire triangle adds up to 180, right? So if the bottom is 30, then the other has to be 60. Now there's another one. You guys also have to know that one with 45. So for the 45, if I draw the triangle for 45, now you should have this in your notes. I just want to mention it one more time. Wow, that's a weird triangle. Let's draw it this way. So you also have to remember this one, the 45, 45, 90. So that's 90. This is 45. If this corner is 45, then this corner is also 45. And this is 1, the hypotenuse. The side lengths are square root of 2 over 2. Square root of 2 over 2. That's the other triangle you have to remember. So 30, 60 and 45, 45. So Matthew, let me know if you have any other questions on this.
No, that's it. Thank you.
Okay. All right. Anyone else have any other questions?
I wanted to ask if we could do a question with the area of a natural log.
Area of a natural log. You mean the way we derived the definition of natural log? So you don't have to worry about area of natural log. We just use that as a interpretation of how we define natural log and E. That was the derivation of that. But you don't have to worry about the area of those rectangles that we constructed underneath the curve. Don't worry about that. Amy, did I answer your question? I think that's what you're
Yeah,
asking.
thank you.
Okay. All right. So yeah, so that graph and those rectangle stuff we did in class, that was just to get to the definition of E and definition for ln. Those were the key ideas. But I'm not going to ask you find the area underneath the curve, blah, 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 using certain rectangles. That you'll see in calculus. So we'll hold on to that until you get there. All right, any other questions before we go? Okay, well, if you guys are good, you are good to go. Make sure to get some rest. It's important that you get enough sleep before you come in for the test, and make sure to go over every bullet point from that study guide. All right, so I will see you guys the day of the final, and hopefully you guys will do well. Okay, so good night, everyone.
Thank you.
No problem.
Thank you.
No problem.